Okay, guys, this is your roller coaster project, and I want to make sure you understand everything about it. This will be check your Google Classroom so you'll know when it is due. So our objective is use what you know about piecewise functions and piece together functions to make a roller coaster design. You will use Desmos to help you put together the pieces of your coaster. Your final project will be hand drawn on graph paper. Okay, you must use at least 5 pieces. Okay, at least means 5 or more. Okay, so the minimum number you can have is 5 pieces. It must not kill your passengers. Okay, so it must be continuous and have no gaps. Now, I understand velocity and gravity and all that's with roller coasters. I'm not checking things like that. I'm checking that it's continuous and has no gaps. Your roller coaster must end at the same height that starts. So if you start at 0, 0, then your Y value must be at 0 on the end. If you start at like 0, 8, then at the end, wherever your graph ends, should start at a height of 8. Okay, your X is time, your Y is height. Okay, you may use any of these functions, but not limited to linear, quadratic, cubic, exponential, radicals, absolute values. If you want the little circle in it, you may have to look up a circle function, so you can put those in there also. You must have at least 3 different functions. So out of all your functions, you can't use all linear functions. You have to have at least 3 different functions. So like linear, quadratic, cubic, linear, quadratic, exponential. So 3 or more of your 5 pieces have to be different functions. You will include calculations that ensure the end of each piece of the roller coaster meets up with the beginning of the next piece. So the end of your function 1 should meet exactly where function 2 starts and continue to your function step. Your graph will be plotting time, which is x, against height, which is y, and your roller coaster should be at least 30 seconds long. So that means on x, it should extend to 30 seconds. All right. You should have a sketch of what you want your roller coaster layout to look like. We will give you graph paper. Create an account on Desmos so you can save all your work as often as possible, and you're going to share that link with me. This is not supposed to be a quick project. We've given you a couple days in class, and you will have about 3 or 4 days until it's due after your days in class. You will turn in. Your roller coaster must have a name. It has to be a hand-drawn graph on a piece of roller coaster, your hand-drawn on a piece of graph paper, a link to your Desmos project, a table with your functions and their domain restriction, the analyst page, and your calculation page. All right, so here's your calculation page. Okay, so say my first function is y equals x, and it ends at 2, 2. Okay, so must include calculation. So if I plug 2 in place of y and 2 in place of x, then it checks out there. Okay, the beginning of my next one has to be 2, 2, because if my first one ends at 2, 2, the beginning has to do that. So whatever your function is, you will work those calculations out, and you will continue for all 5 pieces. Okay, wherever the first piece ends, the second piece begins. The end of the second piece should be the same as the beginning of your third piece. Reach out if you have questions. And then here, this is going to be your table from Desmos. Okay, so let's look at Desmos real quick. Let me get a new graph, and I would label this graph Missy's roller coaster project. Okay, that way it's saved. I can see it over here. I can share my graph with Miss Lewis. Okay, so I'm going to start off with y equals x. I want the domain restriction to be to have x is greater than or equal to 0. computer. So let me do it on Desmos on my computer instead of this. So let me show you Desmos on my computer. Okay, so we'll cut this off. So y equals x, and then you're going to put the brackets from there, 0 to 2. So from 0 to 2 is my first function, and that's 1. Okay, then this is going to be my second function, and it's going to go from 2 to 3.4. Now you can have it to go below here. Just realize that 0 is the ground, so that would be like a tunnel. So normally it should be staying above. And if you wanted this to move up some, you could put like +4 or 5 on there. And then if that's the case, you would need it to be at 5 here. So instead of +2, I would do +5. And then if I wanted it to go down some more, I could do like 6 here. That's too much. 4, oh, I like that. So then that's 2 functions. Here's where my end piece is there is at 4, 1. So if I go back to my roller coaster project, then if I'm here, I'm at 2, 2, and then the end of my second piece is 4, 1. So I would write my function here, plug it in to show the math that it works out, and then my third piece is 4, 1 here. Okay, so then on page here, these functions here, what I'm looking for here is what's in here. Okay, so I would write that first function in my paper, and then I would write my domain restriction. Show it to you real quick so you can see what I did there. So there would be my function, my domain restriction. Okay, I do recommend you always use equal to, because if you say, for instance, here, you just use that, look, it's not going to show you the endpoint. It's going to say for undefined. Okay, so you do need to use the less than or equal to sign so that when you click on it then you can see the 4, 1. Okay, so then you would add some more functions in here, and you should have at least 5. When you are doing your table, you only have to put your first 5 in, okay? So only the first 5 into your table. And then here, you're going to identify the domain and the range, the max and the minimum, increase and decrease in behavior, y-intercepts, and include how it applies to your roller coaster. So you may say something like this. My roller coaster starts at 0, 3. That is my y-intercept and the beginning of the roller coaster. It increases from 0 to 2. Remember, we use x values there. And that is the first hill of the roller coaster. And then from 2 to 4, it is decreasing as I go down the hill. And then you would continue to talk about that. So that's what we're expecting here. We're not expecting you just to label it, but we want you to tell us how it applies to your roller coaster. Okay, then this is how you're going to be graded. If it has a name, you're going to get 1 point. And Missy's roller coaster is not a name, kind of like the Superman, the Batman. So make up a cute little name. Hand-drawn graph that Desmos turned in, 2 points. Okay, hand-drawn graph matches Desmos. 1 point for function that matches, so up to 5 points. Coaster ends at the height that starts. So in my coaster here, I started at 0, 3. So whenever I get done with it over here past 30, because remember it has to be 30 seconds, then it should be ending at 0, 3. Or not 0, 3, but like 33. Okay? So end and starts at the height. Correct calculations, proven continuity. That's this page here. And so that's going to be 9 points. Table with domain restrictions, you're just copying what you put in Desmos here. As long as it matches and it's your first 5 function, you're going to get the points there. And then the last part, domain and range, minimum, maximum, increase, decrease, y-intercepts, and in behavior. If you do your Excels, you're going to get 10 bonus points. And then also the other extra credit that you receive for bringing supplies in and your syllabus. So you have a total of like 117 points. Okay, guys, so please reach out if you have questions about your roller coaster project. I hope this helped you understand it. Have a great day.